Okay, good morning everyone. Today we are going to discuss about the new topic called dangerous substances, reaction hazards, bulk storage operations. So this unit focuses on this topic mainly focuses on understanding the risk associated with the handling hazardous materials, identifying chemical reaction hazards, and ensuring safety in bulk storage operations. It is crucial for chemical and process engineers to be familiar with these topics to design safe systems and prevent industrial accidents. Okay, okay, let's get started of this unit. We know what is introduction to process safety management. I just re-emphasize here again. Okay, so process safety management is a systematic framework for managing the risk associated with the hazardous chemicals in okay hazardous chemicals in industrial processes. It aims to prevent accidents, including fires, explosions, and toxic releases, right, by implementing engineering and management controls. So, PSM is a method used mainly in industries like chemical plants, refineries, and manufacturing units to keep operations safe, especially when dealing with dangerous chemicals. So, some chemicals can catch fire, some chemicals can explode, some chemicals release toxic gases. So, if not handled properly, they can cause serious accidents that harm people, property, and the environment. Right? So, this introduction we have already seen. Anyway, just I want to re-emphasize again. Okay, what are the dangerous substances that are handled normally handling in chemical process industries? Already we have come across with some chemicals, right? We would have come across with some chemicals, even though we are going to discuss detail about it. So dangerous substances are chemicals, gases or materials that can cause harm to humans, property or the environment. This harm can come from them being toxic. Toxic means poisonous, flammable. Flammable, no, yes, catch fire easily. Explosive, so can explode chemical. Corrosive can damage materials or skin. Reactive can dangerously react with other substances. So due to their toxic, due to their flammability, and due to their reactivity, and also due to their explosive nature, right? These chemicals, right? These chemicals handled properly, right? Handled properly. Okay. So classification of dangerous substances. So we have flammable substances, so that catch fire easily. Example: methanol, propane, hydrogen, and ethanol. Toxic substances, harmful or deadly if inhaled, swallowed, or touched. Examples: ammonia, chlorine, hydrogen sulfide. Explosive substances can explode under certain conditions like heat or pressure. Example: nitroglycerin, ammonia nitrate. Corrosive substances can burn skin or corrode metal, right? Example: sulfuric acid, hydrochloric acid. Reactive substances react violently with water, air, or other chemicals. Example: sodium, potassium peroxide. So each type needs a special handling, storage, and a safety measures to prevent accidents, right? So we will pick any one, and so for example, flammable flammable substances. So if you pick flammable substances like methanol, propane, and hydrogen ethanol, uh, methanol usually used in antifreeze and as a fuel burns with an invisible flame. If you take propane, common in gas cylinder for heating, cooking, highly flammable. Hydrogen, yes, we know it is highly extremely flammable, burns rapidly and explosively. Ethanol found in hand sanitizers and alcoholic beverages catches fire easily, right? So safety measures, generally proper storage, handling precautions, fire suppressions, training and PPE, that is personal protective equipments like gloves, goggles, and flame resistance. So workers can be trained properly, right? Handling precautions you must have. So this way, these dangerous substances are classified. Okay, we'll move to next slide. Hazards associated with dangerous substances. So what are the kind of hazards which are associated with dangerous substances? So we have fire explosion risk, fire explosion risk due to flammable vapors and gases, toxic exposure and environmental pollutions, toxic explosions and environmental pollutions, right? So fire and explosions risk, if you see, some substances release flammable vapors or gases. So if these vapors meet a spark or flame, it can cause a fire or even a explosion. Or even a explosion. If common in chemical plants, fuel stations, and storage facilities. So some substances releases flammable vapors or gases that are common in chemical plants, fuel stations, and storage facilities. So toxic exposure, some chemicals are poisonous if inhaled, swallowed, or touched. So this can cause breathing problems, skin burns, or long-term health issues like organ damage. So safety gear like gloves and mask is essential when handling such substances, right? And we have environmental pollution. Spills or leaks can contaminate air, water, or soil. So this harms not just humans but also animals, plants, and ecosystem. So proper storage, leak detection systems, and emergency plans help prevent this, right? Help and prevent this. So these are the hazards associated with dangerous substances, fire and explosion risk, and toxic exposure, right? Toxic exposure, and we have environmental pollutions. Okay, environmental pollutions. Okay, fine. So we'll go to next slide. Okay. So control measures for dangerous substances. So what are the type of control measures we can take for dangerous substances? So proper storage with the secondary containment, use of personal protective equipment, ventilation and monitoring systems, emergency response planning. So proper storage with the secondary containment. So store chemicals in suitable containers like flame proof or corrosive resistance. Secondary containment, means having a backup like a tray or barrier to catch leaks or splits. Use of personal protective equipments. Workers should wear gloves that is chemical resistant, goggles or face shields, respirators or masks, and protective clothing. So PPE reduces risk of exposure through contact or inhalation. So ventilation and monitoring system use proper airflow systems to avoid buildup of harmful vapors. Monitoring systems detect leaks, toxic gases, or unsafe conditions early. Emergency response planning have a clear action of plan for accidents like chemical spills or fires. Include fire drills, evacuation routes, spill kits, first aid procedures. Okay. So these measures are key parts of process safety management to keep workers and the environment safe. Right. Right. So if you see real example of chemical plant safety measures, proper storage, that is chemical tanks for flammable liquids like ethanol or benzene are stored in well ventilated areas. Secondary containment means these tanks are placed inside concrete bunds or spill trays to catch leaks. So use of PPE, workers entering hazardous zones wear flame resistant suits, gas masks for toxic vapors like hydrogen sulfide, gloves and goggles for handling acids like sulfuric acid, and ventilation and monitoring. So the plant uses gas detectors for early leak detection, alarms to warn of high vapor concentrations, ventilation fans to remove flammable vapors, right? And we have emergency planning. In this case, emergency response teams are trained for fire, explosions, or chemical leaks. Mock drills are conducted monthly. Facilities have stations, fire extinguishers, and hazmat suits readily available. So these safety steps reduce accidents and protect lives, and they are part of what's called a safety culture in the industry, right? So these are control measures for dangerous substances we have. Okay. So next we are moving to reaction hazards. Reaction hazards. Okay. Next we have reaction hazards. So reaction hazards arise from uncontrolled chemical reactions that can lead to fires, explosions, pressure buildup, and toxic gas releases, right? So reaction hazards arise from uncontrolled chemical reactions that can lead to fires, explosions, pressure buildup, and toxic gas releases, right? So there are types of reaction hazards: runaway reactions, thermal decomposition, gas evolution reactions, incompatible reactions, right? So reaction hazards happens when chemical reactions go out of control, right? So this can cause fires, explosions, pressure buildup, and the release of dangerous gases. So what are the types of reaction hazards? We have runaway reactions. So these are reactions that release a lot of heat. So we call this as exothermic reaction, right? Example, polymerization of acrylates. So if they get too hot, they speed up even more. This can lead to explosions. So that is what the example is: polymerization of acrylates or polymerization of catalyst. This is a runaway reactions example. Next, coming to thermal decomposition, when unstable chemicals break down because of heat, when unstable chemicals break down because of heat, so this process gives off more heat and can make the situation worse. Make the situation worse. So gas evolution reactions, that is, some reactions produce large amount of gas. If the gas gets trapped, pressure buildups. This can cause containers to burst or explode. So incompatible reactions, we have when you mix chemicals that should not be mixed, they can react violently. So this can cause fires, toxic gases or explosions, right? So this we call this as incompatible reactions. Incompatible reactions we call, right? So definition of reaction hazards and the types of reaction hazards. So we have, okay. We'll go to next slide, that is controlling reaction hazards. So what are the steps we can take to control the reaction hazards? So first one is process design, and second one is hazard analysis, and emergency relief systems, real time monitorings. So controlling reaction hazards, we have a process design. Yes, design the process so that temperature and pressure stay within the safe limits. This helps to prevent runaway reactions and pressure buildups. Hazard analysis, yes, use tools like hazard and operability study and risk assessment. So this help find possible dangers in a process before something goes wrong. Emergency relief systems, install pressure relief valves or venting systems. So this protect equipment by releasing pressure safely if it gets too high. Real-time monitoring, use sensors and alarms to watch the process constantly. They detect anything abnormal like high temperature or pressure, so you can act quickly, right? So process design and hazard analysis, emergency relief systems, real-time monitoring are controlling reaction hazards. Okay. And next we have bulk storage operations. So what are the bulk storage operations we have in this? So bulk storage operations refers to the large scale storage of hazardous substances in tanks, silos or containers in chemical plants and refineries. Okay. So bulk storage means what? Storing large amounts of hazardous materials like chemicals or fuels in big containers such as tanks or silos. This is common in chemical plants and oil refineries. So types of bulk storage tanks are fixed roof tanks used for non-volatile liquids, liquids that don't easily evaporate. Example, water and diesel. Floating roof tanks used for volatile petroleum products easily evaporate. The roof floats on top of the liquid, reducing vapor loss. Example, gasoline. Pressurized storage tanks designed for liquefied gases under pressure. Example, propane and butane. Cryogenic tanks store gases that are liquefied at very low temperatures. Example, LNG, liquefied natural gas, liquid nitrogen, right? So these are the methods, types of bulk storage systems, that is tanks, fixed roof tanks, so floating roof tanks, pressurized storage tanks, and cryogenic tanks. Cryogenic tanks stores gases that are liquefied at very low temperatures. Example, LNG, liquefied natural gas, liquid and nitrogen. These are cryogenic tanks we can use, right? We can go for cryogenic tanks. Next we have hazards in bulk storage operations. Okay, so what are the hazards we have in bulk storage operations that we will discuss in detail. So hazards in bulk storage operations: tank rupture, leakages and spills, vapor release and boiling liquid, expanding vapor explosion, that is BLEVE. Simply we call this as BLEVE, that is BLEVE, BLEVE. Okay, BLEVE. And the safety measures in bulk storage operations: tank material selection, leak detection systems, fire protection system, proper labeling and signage. Okay, fine. So tank rupture means happens due to too much pressure or weak tank structures, can cause explosions or major chemical releases. Leakage and spills, chemicals leaking out can cause pollution and harm the environment. Vapor releases, gases can escape and lead to fire or explosions, especially with the flammable substances. BLEVE, boiling liquid expanding vapor explosion, happens when a pressurized tank overheats, causing it to explode violently. So, what are the safety measures in bulk storage operations we can go? So, tank material selection: use materials that resist rust and corrosion to prevent tank failures. Leak detection system: install sensors that monitor for leaks and raise alerts early. Fire protection system: set up foam systems, sprinklers and firewalls to control fires quickly. Proper labeling and signage: make sure tanks are clearly labeled and meet safety standards so workers know what's inside and how to handle it, right? So tank material selection, leak detection systems, fire protection systems and proper labeling and signage are safety measures in bulk storage operations. So this kind of safety measures we can go for bulk storage operations, right? So what are the regulatory compliances and best practices we can go for handling hazardous materials and bulk storage systems? So there are key safety regulations. There are key safety regulations about for regulatory compliance and best practices. So we have OSHA, that is Process Safety Management Standard 29 CFR and 1910-119. So OSHA Process Safety Management, this is a US standard that helps industries safely manage hazardous chemicals by focusing on things like equipment maintenance, safety systems, and worker training, and EPA risk management programs. A rule that is 40 CFR Part 68 by the US Environmental Protection Agency to prevent and reduce the impact of chemical accidents by requiring a detailed safety plan. SEVASO 3 directive, a European law that is made to prevent major accidents involving dangerous chemicals and to limit their consequences. NFPA standards, guidelines made by the National Fire Protection Association to prevent fire and explosion risks in industries handling flammable or dangerous substances. So best practices for safe handling, these are the things companies should regularly do to stay safe. First, risk management assessment and audits. Risk assessments and audits. So frequently check systems and processes to find the possible risk and fix them early. SOPs, standard operating procedures. So create a detailed step-by-step instruction for workers to safely handle hazardous materials. Employee training, teach workers how to identify dangers, use safety equipment, react danger during emergencies. And a spill and emergency response plan. So prepare a full action plan for chemical spills or accidents, including how to stop them, clean up safely, and protect people, right? So employee training, identify dangers, use safety equipment, react during emergencies. So these are the best practices: risk assessment on audits, SOP, standard operating procedures, employee training, and spill and emergency response plan, right? And so regulatory compliance and best practices. Next, we are moving to last slide, that is conclusion side. So we have seen what are introduction to process safety management, dangerous substances, what are dangerous substances in chemical process industries, and the hazards associated with dangerous substances. We have seen and control measures for dangerous substances and reaction hazards, controlling reaction hazards, and last slide, that is bulk storage operations and hazards in bulk storage operations. So we have regulatory compliance and best practices, and finally coming to conclusion. So managing dangerous substances, controlling reaction hazards, ensuring safe bulk storage operations are critical components of process safety management. So a proactive approach involving risk assessment, engineering controls, and strict compliance with the safety regulations can significantly reduce the likelihood of accidents and enhance workplace safety. Enhance workplace safety. So main idea that keeping chemical plants safe requires carefully managing dangerous substances, reaction hazards, and bulk storage. Why it's important? These activities are all part of something called process safety management. So which aims to prevent accidents and protect both people and the property. So how to achieve safety? Do risk assessments to find possible dangers early. Use engineering controls like alarms, automatic shutoffs. Follow safety laws and rules strictly. Outcome: this proactive approach, not waiting for something to go wrong, reduces accidents and keeps the workplace safer. Right? Workplace safer. Okay, that's all for the today class, guys. And if you have any doubt, and you can ask me online or offline. Thank you all for listening to this class. We will meet next class. Thank you.